and welcome to the Ham Sandwich Show. You have me, Greg OH2FFY in Finland, and you have over there, Steve. Hello, Steve. How you going?
Hi, I'm Steve. I'm KD0PXX here in Omaha, Nebraska.
And Steve, we've got a special show today. It's a special about the Yaesu FRG-7, isn't that right?
Yes, it's a lot of work has went into this. Hopefully it shows, and we're going to kind of step you through the FRG-7, or the Frog as it's lovingly known.
Yep, but some people might be thinking, because we're talking about a receiver, and some people might think, why are we talking about receivers on a show which is about amateur radio, which is two-way communications? And that's because history tells us that hams have found it easier to make transmitters rather than receivers. And back in the days when CW was the mode that most hams used, making a transmitter was actually quite straightforward. And once sorted out, that CW transmitter could be modified and become a AM mode transmitter, so the hams could speak to each other. But making a high-performance receiver back then was a considerably much more harder job to do. So many hams used commercially made receivers for that part of the job and concentrated on making their own transmitters. After the wars, there was always has been like a surplus of very high-quality receivers that were ex-military grade, and these were often dumped or sold off for like scrap metal costs, which is very, very cheap. So hams, always being economically minded, were given the opportunity to have very high quality equipment for really next to nothing. So why wouldn't you just take those good quality receivers and use them in your ham shack rather than trying to make something from scratch? So for a long time, many hams operated with bought receivers, and still that continues on, with many commercially made communications receivers still having the facility to be connected to a transmitter and being controlled by the mute jack on the back. So the bond between bought receivers and hams goes back a very, very long way. So talking about receivers on a ham radio show is not out of place. So as we said at the beginning, today's show is about the Yaesu FRG-7 communications receiver. Now, Steve, I'll put up some pictures up on the screen here. We have three radio receivers: the XCR30, which is a solid-state portable receiver you can take on a picnic or to the beach. We have the Yaesu FRG-7 desktop receiver. And we also have the famous Racal RA-17, which is a old tube radio from the 1960s. Now, without saying they've all got knobs, what's the common feature that all these radios have?
Well, if you do a little research, you'll find out that these aren't conventional super heterodyne radios. They use a rather innovative and very clever tuning circuit. And it makes it quite a bit different. And one has to keep in mind that at the time this was designed, I believe the design was before or very close to the early part of World War II. So this became adopted by a few manufacturers, and it's very, very clever. It's quite different, and that's the reason we're going to show you the FRG-7. And I believe that I always mispronounce this gentleman's name, so I'm going to let you pronounce it, Greg, because I don't want to slaughter his name.
Yeah, that's all right. Yes, the type of circuit that these radios all have in common is called the Wadley loop cancelling circuit, and they're affectionately known as the Barlow-Wadley. And it was invented by a guy, we'll talk about him a bit later on, called Trevor Wadley, and he was from South Africa. But before we actually get into talking about the Yaesu FRG-7 and what made it so special, we really got to have a bit of a history lesson. And I know everybody's saying, don't do with the history lessons, but we have to learn about, we have to know about the way that things were back in the old days to be able to really appreciate how special the Barlow-Wadley circuit and in turn the FRG-7 really was. So to start off, we have to go back and think about the superheterodyne circuit. Now, in a superheterodyne, the received frequency gets down converted to the frequency of a radio signal, which is much more easier for the vacuum tubes, because we're talking about back in the old days, but much more easier for them to amplify. Another benefit of the superheterodyne that was found was that it increased selectivity. So there was, when superheterodynes were invented, it was a very big jump in performance of radio receivers. Now, when we're turning the tuning dial of a radio that has a superhet circuit in it, we're controlling the frequency of the local oscillator, and this is also known as the VFO. The problem is that to cover the whole of the high frequency shortwave band, like what you want in a communications receiver, our VFO must be able to tune up to quite high frequencies, and that's not easy. We have varying levels coming out of the VFO's oscillator when we try and tune across that whole range. And what's even worse than that is that we have frequency drift. Now, drift occurs for a number of various reasons. There's a few things that go into it, but one of the biggest things that causes drift is the effects of temperature changes on the components within the VFO circuit. Drift isn't a problem on low frequencies, but it gets progressively worse and worse as the VFO's frequency, or the tuning of the radio, is increased. And no doubt that you've used these cheap shortwave radios that you set them on frequency, and then 10 minutes later you go back and tweak the tuning knob again and again. Some radios just keep on drifting forever and ever. You're always having to readjust them, especially on the upper frequencies. Well, that's the drift. So just try and find myself in the notes. When we have, it's not so bad on an AM mode signal, because the signal is often quite wide, and it takes a lot to be able to notice when a receiver has drifted. But when we're trying to listen to single sideband or CW, the effect of drift is very much more pronounced, and you're always having to go back and adjust the tuning. And remember, we're talking about in a time that was before digital frequency synthesis and phase lock loops, which are common today. So what they came up with for communications receivers and ham radios is this. They would have a separate band crystal and an oscillator for it, and another mixer. And they would do it on a board like this. This is actually taken out of a Yaesu HF transceiver, a Yaesu FT101ZD. And you can see a bank of crystals, coils in there, and in there are a whole bunch of transistors. And what they use this circuit for is when they mixed that with the VFO, they were able to find that they were able to use a VFO of a much lower frequency, and the lower frequency of the VFO drifted less. So I'll explain this again a bit differently. By mixing a VFO of a low frequency and the crystal oscillator of a higher frequency, they're able to get the result of a VFO with a high frequency, but it actually had the drift of the low frequency VFO. So this one here, this operates up to the 10 meter band, which is 28 megahertz. And the VFO that was used in this accompanying with this was running at about 5 megahertz. So they achieved acceptable frequency stability, usable even for single sideband and CW modes. But this problem of having separate band crystals has a problem if you want to cover the whole HF spectrum. Remember, with this arrangement that Yaesu did, we had 12 bands of 500 kilohertz or half a megahertz wide. So even though this is a HF transceiver, it wasn't covering all of HF. So if we want to cover all of HF, we're going to have a whole bunch more crystals. And then you're going to have, if the band is going to be 500 kilohertz across, you're going to need like 60 crystals and 60 oscillators on a board like this to get it to cover up to 30 megahertz. And then you're going to have some really crazy looking band switch as well. So just like today, back then, crystals aren't cheap. So if you can imagine having to have 60 crystals in a HF transceiver, you probably get away with less, but just if that was the case, the costs alone for employing this type of arrangement is going to be quite prohibitive, not really viable. But still, the manufacturers, they wanted radios that wouldn't drift. But making a receiver with full HF coverage with this crystal arrangement is, like I said, just not really a viable option. So we're introduced to the Barlow-Wadley drift cancelling circuit. So this guy from South Africa, a doctor and engineer, came up with this circuit to get around the drift and band crystal problems, and it really was a stroke of genius at the time. The Barlow-Wadley circuit is a variation of the superheterodyne circuit, but instead of having separate band crystals, he did it with one crystal. The single crystal was made to produce harmonics at 1 megahertz intervals, and a filter would select which harmonic to mix with the radio circuit, and that allowed operation up to 30 megahertz. But the genius part wasn't really this part. It was the way that he mixed the VFO and his harmonic oscillator together in 2 points of the circuit. And the way that it was done, there was drift cancelling. So I'll put up on the screen now a block diagram, and in the block diagram here we see that the radio is really made up of two parts. The front part has the drift cancelling section, and you can see the loop round of the circuit here where the various signals are mixed in at different points. At the end of the first section, a single 1 megahertz wide band piece of spectrum is presented to the second half of the receiver. In the second half, which is extremely conventional, you could tune across this 1 megahertz lump of spectrum with the main tuning dial on the front of the radio. Because the signal has been down converted, the tuning of the VFO in the second part of the radio was at a very low frequency and drift was minimal. Dr. Wadley, with his Wadley loop, had achieved full HF coverage with a single crystal with the same level of drift that a full VFO and crystal mixing method, like what this did, same sort of drift as what that offered, which is about 20 times as stable as a conventional superhet radio of the time. Plus, unlike other similar communications receiver at the time, with a Barlow-Wadley circuit, you don't have problems with phantom signal images. So that was another benefit that came out of this type of tuning, this circuit arrangement, which really was quite amazing. But as with all things in life, the Barlow-Wadley circuit isn't perfect. The 1 megahertz wide band of frequencies and the signals within that block, that 1 megahertz bit of spectrum, was being delivered to the second section of the receiver. And that meant that any excessively strong off-frequency signal within that range would limit performance of the receiver. In practice, though, the Yaesu FRG-7, I haven't found that to be an issue. But perhaps it would have been back in the days when we had these megawatt shortwave broadcast stations. While today we're talking about the Yaesu FRG-7, the Barlow-Wadley circuit was used by many other companies as well. And some of the other radios, the Racal RA-17, which I said before, all the way up through to the Racal RA-1218. So there was that Racal actually made quite a few Barlow-Wadley receivers. There was, of course, the Barlow-Wadley XCR30, which is that portable, which I showed you, the Yaesu FRG-7, which is what we're talking about today. And Yaesu also made a lesser known model called the FRG-7000, which I have one just over here, which has also got the Barlow-Wadley circuit. Sears made the communications receiver. Well, actually, they didn't make it. It was a rebadged Yaesu FRG-7, as well as the Sommerkamp FRG-7, which mostly was distributed around Europe. That too was just a rebadged Yaesu radio. There was the realistic DX300 and the DX302, which were very popular sellers, but they didn't quite match the performance of the Yaesu models. There was the Drake SSR1, which is can still be found quite commonly on eBay today. Again, slightly probably missing the mark of what Yaesu had set. And then there's the low SRX30, the Century 21, and the standard C6500, which were basically rebadged Drake SSR1s. So, you know, if you're a shortwave listener out there and you've been around for a while, it's possible that you've either seen or used a radio with the Barlow-Wadley circuit in it and didn't even know about it. The Barlow-Wadley drift cancelling circuit in the Yaesu FRG-7 gave it great frequency stability and full HF band coverage without the need for separate band crystals, all of which was very unusual for the time. So Steve, when we're looking at buying a used FRG-7, what problems do you know of?
Well, if you're going to go shopping for an FRG-7, especially after you've got really excited about its new interesting technology, you know, there's kind of a checklist of things I do. One of the first things I do is I always ask myself, and this kind of applies to anything, is why is it being sold off? If somebody's got something for sale, there's a reason. And it's your job to figure out why. They don't like this anymore. There's always a reason. So you kind of need to, it's helpful to figure that out why. And when you're shopping for an FRG-7 or anything in general, for the most part, looks are everything. So if you take a look at this slide here, this is a recent rebadged FRG-7. This is a Sears, and this is a really good looking radio. This is, somebody dug this out of some closet somewhere. You can see it has the box, and it's got like almost no miles on it. And it started out on eBay, and it went for about $500. We got up to $500. Do you remember that radio, Greg?
Yeah, I didn't see the. I can't remember the auction, but yeah, those pictures look absolutely, you know, incredible. That would be something really, really nice to have.
So this is what you're looking for. Now, let's be honest. The chances of getting something like this are not impossible, but a little bit limited. So you might want to shoot maybe a notch or two down. But again, looks are everything. And to quote Greg directly, I really don't care what the insides look like. It could have a fire in it, but as long as the outsides look good, because I have a hard time redoing the cosmetics. That's a quote from Greg. He probably doesn't remember this conversation, but it is.
I don't remember what I did yesterday, so yeah, you're exactly right. Yeah.
Well, you did promise to send me a lot of money. You're going to do that, right? So anyway, the other thing I do is I was
just going to say, but yeah, you're absolutely right. You know, I don't know how people can do it. I don't know how they can let radios get in such bad condition. Sometimes you see them pop up on eBay. What was that one that we saw the other day that it was all melted? You know, that realistic radio.
It was fire. It's literally, and he wanted some, you know, I guess A for effort for trying. You can always start out high and work your way down. You can never start low and work your way up. But it was basically a big molten mass, and he wanted a couple $100 for it. It was realistic, wasn't it? Yeah, it was. It was a realistic DX302 or 300 or something. But yeah, the front fascia panel is really hard to on all radios. It's, you know, it's the part that people touch when they're using it. So you're gonna see some wear, especially on a radio that's 30 plus years of age. But you know, there's quite a lot out there which have obviously been abused, and you know, I try and steer away from those if possible. But because it's just such a hard problem to try and fix. The insides, you can repair it. You can you know, purchase, you know, parts from donor machines and stick it in and get it going again. That's no problem. But if the outside of the radio is a complete mess, really hard to fix that up. And usually if the outside's a mess, it's kind of a shadowy warning about what's going on inside, you know. So you've kind of bought a double bubble trouble there. You're asking for a kick in the head. The other thing I do too is I usually, if you're going to buy it offline, or if you're buying it with, you know, somebody in face to face, ask some questions. You'll get a feel for what the deal is. I have a hard time with online folks with auctions saying, well, I can't test this, or I don't know how this works, or whatever. You know, we don't live in a bubble. This is the 21st century. We've been to the moon. You can certainly look this up online and get a little piece of wire and at least get some basic testing. You know, either these people just don't care, or there's maybe something to hide. So again, it's an old saying, but it's still true. Buyer beware. You know, you've got the money, ask a few questions, and it'll help you gauge what's going to happen. You know, especially if you get the thing shipped to you, and heaven forbid it gets squashed into a pancake. You know, what's the seller going to do? You know, you need to know those things ahead of time. Now, as far as the electronics, now that we've got past the cosmetics and you've got a pretty face, the FRG-7 is amazingly simple for how really complex it is. There are literally only 2 circuit boards in the thing. One is kind of the RF deck, and that's on the one side there by the antenna jacks. And the other is kind of everything else. It's got the audio amp, it's got the detector sections and the switching in it, and all the electrolytic caps are on that other section. That section is right behind the speaker on the thing. There's one other small circuit board, but I really don't count it very much. It's amazingly basic. So things you're going to run into once you get your new acquisition safely in your little hands there, if it's a runner, you're going to want to do some preventive maintenance. And preventive maintenance nowadays on 30-year-old electronics usually entails replacing some electrolytic capacitors. My suggestion is you give the thing a good looking over and give it a little bath and kind of clean it up real carefully and see what state it's in and kind of take notes. You may have to use some chemicals to clean the switching and stuff, but most of the time these things pretty much just run. Now, stuff I've noticed on some of the sets I've gotten a hold of, and this is also documented on the internet, one of the other things you'll see is there's some, I believe these are polystyrene. They're little green, they look like little pieces of candy, kind of chiclet gum capacitors. They're on the big board behind the speaker. And a lot of times the tops split out, and you can replace those with some modern film caps. If you kind of have a nostalgia, want to keep a nostalgia feel to the radio, you can buy kits of those capacitors for as little as a couple hundred different a couple hundred sets of values for $14 off of online auction places. You know, you can get those cheap enough. So as far as recapping the FRG-7, it's pretty basic. Almost all the caps are on that one board. There's one hidden underneath, if you take a little look underneath there. And that's just an axial lead, and all that capacitor does is kind of dampen the meter on the thing. The rest of them are pretty basic. There's 3 main caps for the power supply. It's downhill from there. You know, it's a pretty easy job to do. A few other things you may run into. You run into some dirty switches. I like to use the little applicators. They're like little needle eyedroppers for putting the cleaner for the switches in there. I kind of try and resist that fire hose spray can stuff. I know some of you won't be able to do anything about that, but do the best you can. One of the other things you'll find on the FRG-7, don't be afraid to do this, is there is a pair of switches on the front. There's a power switch and a dial light switch. A lot of times the switching part gets snapped off or lost, and it's pretty easy to buy a replacement switch. They're $12, and it's 6 wires later, and you can replace that switch easy enough. If you're really lazy, you can buy the replacement switch, and you can actually unhook that plastic face and snap it back on. But like Greg and I had a conversation earlier, the reason those switches pop off is they start to get stiff. The mechanics get stiff, and no amount of cleaning or fiddling around really will help them. So yeah, just beat the rush and replace that. And you don't have to do this all in one day. You know, you can do it little stages at a time. I've got a hold of a radio recently. The power switch was locked up on the thing. Basically, for a couple days, I just turned the thing on and off by removing the line cord from the main socket until I got a replacement switch in there. It's not a drag race. You know, part of the fun of all these types of things is taking your time and doing a quality job and enjoying it.
Yeah, I've had problems with those the red power switches before, and they really, when you get your new old radio, the power switch should be, if it's working properly, should be very light effort to be able to put into to turn it on and off. If it's really, you know, quite a significant amount of effort and it's to move it, you know, you're going to be heading towards a new power switch very, very soon. So the thing is that switch should be very, very light and very, very easy to turn the radio on and off. If it's a bit stiff, you're going to be getting a problem with that sooner or later.
Yep, and just beat the rush. Like I said, they're $12 a switch. They're, you know, they're pricey because they're limited. You know, they're 30 years old, and that's just the way it is. So you got that cleaned up. One of the other things you may run into, and this would be a question you would ask ahead of time, would be on the back of the unit, there's a big door. And behind door number 1 is a battery compartment and battery holders. Now, there are some versions of the FRG-7 that don't have this. It was kind of an option. And you may want to ask or get some pictures of that. And there's a lot of times, if the batteries have sat in there, then all that electrolyte is run down and can run it down across the radio. And depending on which way the radio was stored, it can make a hell of a mess. Personally, the battery setup on the FRG-7 was a big disappointment. The original radios I got a hold of, none of them had those battery compartments, and I went to a lot of trouble to make a set and modify the door and get it all slid in there, and it was a big kind of performance disappointment. I thought it would be cool, but I don't know. So unless you're really a purist or you have some very specific reason, I don't know if I'd worry too much about that. But that corrosion, there's very little you can really do about it. It can really chew the radio up. Now, if you're not afraid to tackle that kind of stuff, or when it gets some sandpaper out, knock yourself out. But be aware that there are a lot of those radios flying around that have had the batteries set in them, and that really, it's kind of on the list of things to avoid.
The first 3, I've had a few. The first 3 Yaesu FRG-7s that I had in Australia, they didn't have the battery holder and the removable door. The door was there, but it was like a plate and like plastic rivets on it. So it did seem to be like an option, which maybe the Australian ones didn't, you know, wasn't offered with. So I can't remember seeing any magazines which said that this was a purchasable option. So maybe in some markets there just wasn't the choice. But interestingly, all of the radios, even if they didn't have the removable battery carrier or carriage, whatever you like to call it, it still had the wiring inside to fit it and ready to go. So if you did want to, like you say, put in a battery carriage, if you found one, you could actually fit it into a radio which didn't have that as the option when it was new.
Yeah. The FRG-7 actually has 3 ways to power it. There's just mains power or you know, standard wall power. There's that battery, and it's a battery pack. And a quick, easy way to see whether the radio has that battery pack option, there are 4 screws. There's, like Greg had mentioned, there are 4 plastic kind of snap type fittings, and inside that perimeter are 4 little screws. If you see the 4 screws, it's a good chance that that battery pack is there. The ones that don't have that, there's no holes drilled for it, so it's kind of just a dummy plate. The other way you can power that radio is there is sort of a power coaxial type little jack from the back, and I would suggest if you're just bound to determine the power of the unit with DC, that use that. That's a better way, and just kind of leave the battery pack alone, let it sleep in its little cubby holder. Now, some of the other stuff you're going to run into potentially are, I've had a lot of trouble with dirty grounds, and this is over on the megahertz board. It's a very tiny little board, and it's right behind the band switching or tuning board. in the front there. And it's just a little board that sits up there, and there are 3 Phillips screws. And every one of the radios I've gotten a hold of, I've had to take those loose and clean them and then tighten them back up. And I don't know how you have 3 pretty firm mountings that go to heck, but somehow corrosion gets in there and causes it trouble. One of the things you can see is that the megahertz control is off by a band. You know, instead of being in the broadcast band, you'll have to tune up another 100 or another megahertz on either side, depending on which way the thing goes. It's kind of an unusual problem. What it's doing is it's doing something to that little local block oscillator there. So the easiest thing to do is just beat the rush and remove those screws one at a time. You can do it with a Phillips screwdriver, kind of clean back in there, and it'll straighten it up. Other than that, there are really very few problems. Other than I haven't personally seen any of these, but I believe Greg has. There's sets that have the front end FET blown out of there. And maybe you can elaborate. Have you had that problem before, Greg, where the FET's blown out of the front end?
Yeah. Yes, it does happen. The MOSFET that's in the front of the FRG-7 doesn't have internal diode protection as standard, so they can get damaged from nearby lightning strikes. Of course, we're not talking about a direct lightning strike, which will take out any radio connected, but you know, if you have the radio connected to a rather large antenna and lightning strikes, you know, a few miles away, then it can very easily damage these sensitive FET transistors in the front end. But this isn't just a Yaesu FRG-7 problem. It also happens to other radios as well that don't have the internal protection. Now, we're going to answer a question from Craig in a minute, but before we get to that, was there, Steve? You can say whatever you like about the MOSFET problem, but maybe you want to also tell about this LED lead lock modification that you've got going on.
Sure, we can talk about that. Like a lot of things in the world, this idea wasn't an epiphany. I just didn't appear out of space. I wasn't like I woke up in the middle of the night. I actually got the idea from Greg. Greg had a little video. Maybe he'll put a link down below here for us. And the FRG-7 has a kind of an unusual tuning. I'm going to call it a feature or quirk, which is the megahertz knob, which is kind of the band knob. When you tune it, there's a little red LED there that says lock. And it's counterintuitive to the way it works. The way it works is that when the circuit is locked or tuned correctly, the light goes out. And my personal opinion is the reason that is done that way is if you look at the FRG-7, the whole thing is very power conservative. It literally is about 10 watts worth of electricity. So this is kind of a reverse logic to keep the power consumption down. Now, granted, the world's not going to come to a tragic end because some LED's on somewhere, but you know, you never know. So it's counterintuitive. Greg's modification was to use a bicolor LED and replace that. And he has set up the circuit so when the circuit is out of lock, the light is red, and when it's in lock, it's green. So it's a little bicolor LED. And this is something you can do. His circuit's pretty basic. It's pretty easy to do. It's not anything horrible. I'm kind of a fusspot, and it doesn't mean that Greg's circuit is wrong or incorrect. It means that I don't like it. But like a lot of ideas on the internet and the world in general, you can take somebody's idea and kind of bend it to your will. And so I set out to make a new circuit, and we'll show you that here. And it's real basic. I pretty much just made it on some basic punch board or perf board. And up underneath the radio, I installed it. I installed it on some double sticky tape, so it's servo tape. I have a real issue with modifying and drilling big holes in radios. There are plenty of radios out there that are beautiful pieces of equipment, and somebody's taken a 3/4 inch drill and ground a big hole in it. So one of the goals on my modification was to make it so it was reversible. The other goal was that the LED that Greg had obtained had 3 leads. Basically, it's 2 LEDs in one bottle, and there's a common lead that's shared, and then each LED is fired separately. Well, in order for him to do that, there's a tiny little circuit board that's about the size of your little fingernail that holds that LED. It's back behind the unit. It's off. If you're facing the back side of the radio, it's to the right of the tuning dial. It's held in with 1 Phillips machine screw. And Greg had to modify his circuit board to accommodate the 3 leads. And I personally didn't care for that. Again, it doesn't mean his idea was incorrect. It means that I'm just being picky. I found some LEDs where they reverse the LEDs and make them back to back, where it only had 2 leads, so I could do a direct replacement for that. And I'm the same person that took the old LED and glued it inside the radio, so years later somebody can say what the heck that's for. So my circuit is just a tiny bit different, but it's, if you look at the layout or the drawing here, it's sort of a kind of a seesaw type thing. There are 2 basic transistors, and when the circuit, the signal comes from the FRG-7 when it's in lock, it basically turns one LED on and the other LED off, and it rocks back the other way and turns the other one that was on off and the other one on to kind of flip-flop back and forth. It's pretty basic, and a few little things you can do there. The way that circuit is laid out, there's a resistor in there that kind of controls the power consumption for that whole circuit. You can tinker with that a little bit if you want to adjust the brightness of the LED. Also, the 2 current limiting resistors in line there for each LED, you can adjust the brightness. The bad thing about a lot of those red-green LEDs is one LED always seems perceivably brighter than the other, and you can tone that down and fiddle with it. My suggestion is you build this up on a little circuit board and kind of tinker with it off board before you put it inside the radio. Again, I stuck that on the bottom. Maybe something more permanent was in order, but I don't know. It was an experiment as more than anything, just to see how it was going to work out. That's
yeah, I liked your circuit, and I've seen a few of the circuits around that use the 3 wire 2-color LED like what I've got. There's a few circuits that use that type of LED floating around, but I haven't seen anyone try and do it with just a 2-lead 2-color LED like what you've done. So that was quite amazing. And yeah, the brightness, in my one, which is just over there, the green was so bright that it was like boring a hole in my brain when the radio was operating. So I had to put in quite a whole bunch of resistance in that the lead going to that LED to get the green to be a lot more gentler on the eye. It doesn't matter if the red one is bright, because it's meant to be warning you of a problem, but the green one, which is on all the time, should be realistically bright, not boring your brains out.
Yeah, it helps if it blends in a little bit. Like I said, my suggestion is you build the circuit off board and you fiddle with it to your heart's content and kind of get it where you want it, and then think about installing it. And if I get some time, maybe I'll make a separate video about that. I kind of saved this for this video, and if we need to touch up on it or look at that. But the other thing I noticed too, and Greg had pointed out, is the way his circuit works. There are potentially times when both LEDs can come on. It's a very, very small area when you tune the megahertz control. When that does that, the LED looks kind of orange or kind of yellowy. On mine, it goes out. So it's either red or green. There's no in between. But if you manage to fool around and get it in there, now that I've mentioned that, people are going to start doing that. The lighting just goes out. It's a very, very small area. So I don't know. It's kind of potato. Originally I was going to use digital circuitry to do this, and I thought, really, I'm kind of swatting a fly with a bazooka here. There's what is there, 5 parts in that whole circuit? There's nothing in there.
Yeah, it's very, very low. The component count, I think, in yours is even less than what's in mine. So really, really simple DIY modification that anybody could do.
And it's something that's it's actually pretty beneficial. You know, there's nothing to stop you from making a circuit that just reverses the logic in the onboard lighting. There's nothing to stop you from just leaving the thing alone. It's not without its charm. I don't know. It's just kind of a fun little personalization. And like I said, again, you know, I got the basic idea from Greg, kind of molded it to what I wanted to do. You know, if you want to get the basic idea from me or get the basic idea from Greg, kind of mold it to what you do, what you'd like to do. I say knock yourself out. You know, you can use different transistors, experiment around. All that stuff is literally junk box stuff that you can get out of a, you know, probably an old video player you got at the junk store or something you're going to throw away. There's nothing super critical there.
Yeah, it's a very, very simple circuit, and actually I can't take credit for the one that's in mine. It was a design which I found on the internet, so it's something which probably has been reproduced by many people. But you know, and I'm not really a person that's really keen on like trying to find every single thing to modify, but this is a real useful addition, which really it should have been like that from the factory. It's I think quite beneficial for the radio to have the dual color LED lock light. But get on to Craig's question from the blog. Craig, let's see his name, Nuring is his YouTube ID, Craig Nuring, I think it is. He had a problem with the front end FET with his Yaesu FRG-7, and he was wanting or needing to replace it, and he'd been trawling the message boards on various places, and there's always, if you speak to 10 people, you're going to get 15 different suggestions about which part to replace it with. And as the original ones discontinued, well, I think many of the ones that are sold online that are on the same part number are just cheap knockoffs or some other pirated things. So I don't think that you can actually get the original ones anymore. So you're going to have to probably do some sort of replacement one. So Steve, what's been your experience with the replacement of the front end FET issue?
Well, like I said, I have yet to get a hold of a frog that had the front end blown out of it, but I did get a hold of its, I don't know, evil brother sort of ish, which is the FT101, and it has almost identically the same front end in the thing. And the one I got a hold of was just about blown out of the socket. That's one little interesting difference is the 101 is socketed and the 7 is not. So you're going to have to do a little bit of soldering. So be a little thoughtful and careful. These circuit boards are pretty old. Try not to overheat them. You're going to rip a trace up. So just do your best. My suggestion is if you're 100% sure that the FET is bad in the front end, and there's a picture of the FET there, it's pretty easy to figure out. Is maybe think about just clipping the leads loose of it and taking the body off, and then on the other side heating it with your soldering iron and your desoldering tool, and just plucking the leads out one by one, and then you won't have that trouble. What parts I found, I kind of led myself on a merry chase. I actually did find an OEM replacement part. It wasn't cheap. It was about $5. I had to buy 2 of them. I also, and I'm still kind of puzzling about this a little bit, I did find another OEM replacement, but it's a little bit more expensive. It's about $10, and it involves basically cannibalizing some old equipment. So if somebody has done this ahead of time, then you don't have to feel bad about brutalizing some old equipment. There are some aftermarket replacement transistors like the Newtone and the ECG and SK. Those were real popular in the 80s. They were just generic off-the-shelf transistor or replacement FETs. What I've come to the conclusion is that most of the dual gate FETs pretty much work in here. They all work, but how well they work is kind of interesting. And they even seem to work differently even in the same generic type. There is I'm trying to remember the part number for this. I want to say it's the BP981. It's a little dual gate FET. It's intended to be a FET for the front end of like an FM tuner or a TV, and it's very small. It looks like a little tiny aspirin with 4 legs on it. And you can get those off the internet. Now, I'll tell you right off the bat, I bought 50 of them, and only 4 of them were any good. I believe what I got a hold of was some factory seconds out of some trash can. I had to send them back. Well, basically they billed me for shipping and 4 FETs is what our final solution was. What was really sad about that is those FETs did work very well. Now, to be fair, you'll have to do a little bit of a modification to them. The leads just poke straight out of the side. They almost look like maybe a small RF transistor. What I did was I took some very tiny wires and just quickly soldered them on there and made some little L shapes. And you can see this on the internet. This is not my idea. There's a number of people that have tried this for different radios. And then you can just plug them right back in there and they do work. My suggestion is maybe you shop around. I did see a gentleman in Canada, and he had the exact same problem I did. Matter of fact, he bought the FETs from the exact same vendor I did over a year ago, which tells me that they really don't care. They sold these to him, 50 of them, or 30 of them, I believe is the correct number, and he had trouble and got them to send them back or whatever. And a year later, they're still at this game. So he also does sell these, but if you want to buy them from him, they're about $5 for 2 or 3. They're not horribly priced. My suggestion is if you find a source for these, buy 2 or 3, and then it's like anything. If you have a bad part and you buy a couple of them, you'll never break one ever again. That's the type of deal. But almost all the FETs, I've gotten some RCA FETs, just generic ones from local amateurs that used them for breadboarding, experimenting. They work fine. I stole the little square pack one out of a video player I got at Goodwill. That worked fine. I tried one out of a tuner, a Pioneer tuner section. That worked fine. Some of them work better than others, but most of them work. So that's kind of my experience there. So, Craig's basically prowling around for FETs. I did, and we can put a link to this if you want to. I did buy some through eBay that were guaranteed, and they did work. My suggestion is you find somebody who's got some already and has tested and let them do the legwork, unless you like doing that kind of stuff. Probably the real solution here is, when you're done with your radio, unhook it, and then you'll never damage the front end of the radio, and you won't have this problem.
Yeah, exactly. With this, if the FET doesn't have internal protection, you should always disconnect the antenna. But besides these problems that we talked about, the Yaesu FRG-7 is a phenomenally reliable radio, and that's probably what has made it last so long and still have so many good examples of them available for sale today. So they're a modern classic that's, I think, appreciating in value. I saw one the other day go for $400, which I thought was quite crazy. But if they're in good condition, they can really, probably appreciate in value. You're not going to lose your money on one, that's for sure. So, Steve, that's about it. What I've got written here. Have you got any other parting comments?
No, I think we've tried to cover as much ground in as little time as possible. And exactly like Greg said, I really like every one of the radios I've ever gotten a hold of, short of one being just a total basket case, which I got on purpose to see how far. I've actually done very little to them other than some preventive maintenance. They're amazingly well calibrated. They hear through walls, and they're amazingly compact. It's an interesting circuit. It really is. It's probably one of the top 10 shortwave radios that was ever made. I'm going to go out on a limb here. I'm sure I'll get some hate mail about that, but I didn't say where it was in the top 10. But I really have been happy with mine. I can't say enough about them. They're really great machines. And like Greg said, they're starting to command a decent price. The price, since I started looking at them, it's basically went up about $100 for a, kind of average set. Now, if you want to put some sweat equity in one, I'd say, buy a basket case and tough it out, or buy a couple basket cases. But even the parts machines are getting a little pricey. And
yeah.
I think,
go on.
that's, They're a great machine. They really are. Bottom line.
Yeah, I really like mine. I listened to mine. I was listening to it just before we started this this video recording. So listening to Radio Australia on it's coming in great. So yeah, it's definitely one of my favorite radios. Also with the Yaesu FRG-7, which is electrically similar sort of circuit diagram, different circuit but same operating principles. Two of my most favorite radios that I have here. So thanks a lot, Steve. By the way, your YouTube channel is the Time Spiders?
Yes, that's true. And yours is the Ham and Shortwave Radio. If you'd like to stop by and frequent either of our channels. Oh, we didn't mention that we've moved.
Yes, this. If you're watching this now on YouTube, then you're seeing it on the new Ham Sandwich YouTube channel. So if you'd like to subscribe to that and support that, that's fine. And we also have the blog page, which will be updated semi-regularly, telling you about various aspects of the next show that's coming up. So if you'd like to have a sneak peek of what's going to be talked about next time, roll on over to the blog page and have a look, and we'll tell you as soon as we figure out what we're actually going to do.
Yeah, we've had a little hiatus here, and that's probably mostly my fault. I had we had a medical issue that needed attention, and then Greg decided he didn't like freezing in Finland, so he went on holiday.
Yeah, well, you know.
Yeah, right. We didn't even get a T-shirt off of that deal. All I got was
I didn't even send a postcard to my father. So, too busy having fun.
I guess we're all lumped in the same barrel together.
Exactly.
No, we moved. We're probably going to pick things back up again here. That's one of the things that happens. These kinds of things happen, and there's nothing you can do about it. You just do the best you can, and we just pick up the pieces and go on. It's like Greg said, if you want to take a look at the blog page, it's not revolutionary, but it is a kind of a sneak peek. Feel free to comment on any of these channels. Hopefully, if you got some ideas, want to throw something out. Craig mentioned, hey, what can I do about these FETs? We tried to take time to address his issue. Hopefully we got him all covered there. And thanks for stopping by. Doesn't get any better than that.
Yeah. Okay. Thanks a lot to everybody that's waited and watched through this whole video. We appreciate your views and also your feedback that you make in the comments below or on the blog page. We look at them all, and we definitely take these comments and content suggestions. We take these all very, very seriously. So thanks a lot for watching, and thanks to you, Steve, for taking time out of your day, your morning there for the show recording. Thanks a lot, Steve. Thanks a lot, guys.
Bye-bye.